You may be adopting microservices or serverless or agile or lean development principles, hoping to help your teams move faster, to allow them to separate work concerns so that they can move more independently. But in many cases, at least with my customers and my experience, you don't often actually see that much acceleration because the people working on the user interface or the user experience are dependent on a working backend to actually make their application work, or different backend services are waiting for integration with different other backend services. So service A talking to service B, talking to service C, and they're all interdependent on one another to make forward progress. And one of the ways that I think we can help address that situation of those interdependencies is using a technique called contract first API development. So, what we would like to be able to do is we're using those tools, continuous integration, pipelines, continuous testing, microservices, and continuous delivery. But what we're actually seeing is chaos. We're seeing integration issues. We're seeing misunderstandings across teams, and we end up waiting for each other, and we have blockers. I love this quote by Jez Humble. It's something I try to remind myself and my teams about on a regular basis, that regardless of what you think of it, distributed systems are harder than non-distributed systems. And so you need to take that into account when designing for them by not only adjusting the technologies that you use, but the way people communicate and collaborate and the culture around it. So who am I? My name is Devin Phillips. I am currently a senior architect at Red Hat in the consulting services area. I have been working in software development for just shy of 30 years. I've been through the dot-com bust, the old PHP days of the web, and initially my very first programming job was actually working on Xenix, writing C++ code for high-speed laser printers. You can reach me at my socials here on Mastodon or on GitHub. And why should you listen to me? Well, I've been doing this stuff for a long time. I've actually been trying to stay out on the leading edge of all of these technologies and trends most of my career, and helping customers adopt and use them. But why would you choose contract first? Well, because you want those teams to be able to work independently of one another, because you want to be sure that there's consistency. You don't want to have someone write up a specification in plain language, hand it off, and then have misunderstandings where there's blockers, because you need strong guarantees about service contracts. Well, if you're publishing an API to the public, to your customers, to your partners, you don't want that API to be inconsistent. You want those strong guarantees about those service contracts because you want them to be able to integrate and help resell your services. And again, you want to be able to collaborate more effectively. Sorry, let me mute my phone. And because you can also save time by using code generators, testing tools, security analysis tools, and I'll show you a little bit about that and the tooling that you can get with things like OpenAPI, gRPC, so on and so forth. So the traditional development workflow that I've seen with lots and lots of customers, lots and lots of organizations, is somebody goes away, does project planning, and they build this specification. They send this specification to the development teams, they interpret the project plan, and they implement their code so that they are compatible with that specification. And then when everybody's dev done, they try to make it all work together and realize, oh, this team understood this team understood that, and we have to iterate back and forth until we come to a common understanding. And that leads to a lot of rework, a lot of wasted cycles. So, what is the workflow using contract first? Well, you start by building an API specification using a tool like OpenAPI, gRPC, Avro, Async API, whatever. They're all relatively consistent in their capabilities. And One of the ways, especially if you're building a graphical interface to an API or a graphical interface for your users, is by building a validated user experience using that API. And I'll show a demonstration of that at the end. Then you publish your API specification to some sort of service registry, whether that's Apicurio, which is something that Red Hat provides for free, or some other Smart Bear tool, or there are a number out there. And what you can do is you can, via just that API contract, get fast feedback from the people who will consume it, whether that's your UI and UX developers or your partners or your customers. And this is all before you write that first line of code to make sure that they can actually interact with that API and it gives them the information they need in the way they want to consume it. And then from there, you can actually use tools like OpenAPI Generator or Protobuf to generate most of the boilerplate code. And you'll get all of your annotations, all of your controllers, everything. And all you have to do is go and fill in your business logic. In addition to that, I'll show you some tools in a little bit that will help you automatically test versus your API contract and validate your security and things like that. So another possible workflow, as I said, is to use something like gRPC, publish your API specification, and generate those code contracts, all while minimizing the amount of rework that you have to do. So let's learn a little bit about OpenAPI. If you've never used OpenAPI, it's actually relatively simple. It's a very straightforward YAML format. And it allows you to define types, which are object types that you can use for request bodies and response bodies and things like that. It allows you to define endpoints, which are your paths in your API. It allows you to define which verbs on which endpoints. And it allows us to define the parameters for various different types of requests. Finally, within an OpenAPI specification, you can actually define your security. So you can say it requires basic authentication or digest authentication or OAuth 2 or OpenID Connect. And you can even put some parameters about those external security providers into your contract. And finally, second, finally, OpenAPI is very extensible. You can add your own extensions to the OpenAPI specification just about anywhere in the OpenAPI document. And a lot of the tools that we'll be looking at have the ability to use and leverage your own extensions so that you can build on the functionality of the existing tools. So this is what the header of an OpenAPI document might look like. You've got a section about info, the API spec version, the title of your API and a description, which servers your API will be served from. And in fact, you can actually modify this to have enums and parameters so that it's easy to automatically generate different server URLs. You can specify the license for your API. And then we can go in and look at type definitions. So in OpenAPI parlance, we call these schemas. So we might have an order type of type object. It might have some required fields. And then you can define each and individual field for that type quite easily. And then finally, you can choose whether or not you want it to support XML as well and what that XML element type should be named. By default, most OpenAPI schemas are leaning toward JSON and REST, so that makes sense. Here's how you might describe an enumerated type. Works quite well. So then you can take those types and you can use them with your API endpoints like store, order, and you'll see that we have the path for our endpoint. We have the verb that's associated with that endpoint. And here's the really important bit, this operation ID. So if you use any of the generator tooling that is around either generating server-side code or client-side code, this operation ID becomes a method or function name for you to consume or produce that API. So for example, let's say you're a Spring developer and you're creating a controller. If you generate the controller interface from an OpenAPI specification, you'll have a method called place order, and it will have all the appropriate Spring annotations to handle a post request with all of the appropriate request body and parameters and everything, all written for you. And all you have to do is fill in the business logic for that method. You can specify content type. You can either put, as I have here, a wildcard where it will accept any kind of request body and try to decode it into the appropriate type. But you can also be more specific and you can set different content types with different schemas. So, for example, I could have application JSON that takes a schema of order, or I could have text slash XML, and maybe it takes a slightly different schema for the XML. And then we can define our possible responses. 200 okay, and what type of data we expect to get back from a 200, a 400 message saying maybe we have an invalid order. Next up, we can define parameters for our different endpoints. So again, we have our path, we have our verb. Now we're defining parameters of different types. So for example, in this one, we have some query parameters that allow us to specify start and end date for retrieving the orders. And then finally, you can do path parameters. And as you can see, there's a lovely little uh, curly brace embedded order ID here. And then you associate that with a path parameter down here, and you can specify the type and the format. And if you generate code from this, it will help you make those appropriate code changes or code implementations. I talked a little bit earlier about how we can embed security information into our OpenAPI contracts, basic auth, bearer auth, API keys, OpenID, OAuth2. All of this can just be placed directly in your contract. And whether you're using it to generate your code, most of the generators will actually help you set that up if you generate your code, or when you generate client libraries to interface with your API. This will make it easier for your client libraries, because when you generate a client library with, at least with OpenAPI generator, it will allow you, when you do the constructor for the API class or API interface, it would allow you to plug in the information you need to interface with the authentication. So basic auth, bearer auth, API, OpenID, OAuth2. The last thing that I wanted to really talk about here is these extensions. So I'm a huge fan of Eclipse Vertex. I love what Julien and Paulo and Tomas and the other Julien have all done over the last few years. It's a fantastic toolkit for building reactive applications. And one of the things that Paulo and Julien have done is they've built this ability to consume an OpenAPI specification directly. So you can create a Vertex app. You can say, hey, Vertex, here's my OpenAPI YAML file inside of my Java distributable jar file. Read that. And then in the code, it will actually wire these operations up to a Vertex event bus endpoint. And then all you have to do is have an endpoint that handles the business logic. Don't even have to generate any code, which is fantastic. In fact, we're working very tightly hand in hand with one of our big customers right now to improve its capability in Eclipse Vertex over at Red Hat. I also use these extension functionalities for various other things, which I'll show you in my demonstration. So what are some of the tools that you can get with OpenAPI? Now, if you're like me and you've been in the industry for a while and you hear someone talk about code generators, you might just get up and walk out of the room and say, code generators, they're terrible, they're awful, they're the worst. Well, code generation is not the only benefit, and probably not even the best benefit, of using a technique like Contract First or OpenAPI. There are editors that help you modify OpenAPI. There are server implementations. There are client implementations. There are really great testing tools, which is one thing I really want you to focus on. There are great mocking tools so that you can actually validate that API experience with the consumers before you ever write that first line of code. So some editors, I really like, and I may be a little biased here, I really like Apicurio from Red Hat. This is an open source project in the upstream, but if you're a Red Hat customer, we actually have a SaaS hosted service in our cloud platform console. And it's really great for getting started with OpenAPI. It has a really nice graphical interface. It has a really nice way to help you define schemas and objects. In fact, you can take a JSON blob of an object, an example object, pop it in there, and it will generate a schema from that that you can then customize. And it even has a little button when you do that. It says, hey, do you want me to also generate all the endpoints for this object type? And it will create all the CRUD operations, the create, retrieve, update, delete operations. Swagger editor, editor.swagger.io. This is a lot more in-depth. So whereas Apicurio is great for beginners, if you really need to get into the deep details and be very careful about the specifications of your API contract, Swagger editor is actually quite good. There are plugins for VS Code, plugins for IntelliJ, and there are plugins for Eclipse. So server implementations. My favorite is OpenAPI Generator. It if I can, well, not gonna switch screens right now. I'll do it here in a minute. I'll show you here in a bit. OpenAPI Generator can generate client libraries based on your API contract for about 25 different languages and frameworks. It can generate server implementations for about 40 different frameworks and toolkits, and it's very, very customizable. Uh, Most of everything in OpenAPI Generator is based around mustache templates. So if you want the code to be generated the way you want your code, whereas old school generators, you didn't have a whole lot of choice, you can easily modify those mustache templates and just replace the templates that you care about, and the code will be generated the way you want it to be. There are, like I said, is the Vertex Web API contract, Web API services, where the framework, the toolkit itself just consumes the API contract and allows you to connect the operations to specific endpoints. There's another library for Node.js world called MicroTS. This is another instance where it consumes the OpenAPI contract directly instead of generating code. And probably my favorite one for Node.js, admittedly, I'm not a big Node.js server-side developer, but Smart Recruiter's OpenAPI first, again, consumes the OpenAPI contract, but it makes it super simple with TypeScript to connect your OpenAPI operations to express implementation code that just, it works really, really well. So some client implementations, again, OpenAPI Generator covers a lot of different clients. But again, the Vertex Web API client can consume your OpenAPI contract, and then you can just call methods on it instead of having to worry about, oh, I need to go to this path with these parameters. And that. No, you just say, hey, Vertex, call this API, and it will ask you, or it will require you to put in the correct parameters. There is a SaaS tool called API Matic. I'm not as familiar with that, but it seems to get a lot of good reviews online. There's a wonderful JavaScript library called OpenAPI Client Axios. Again, it consumes the OpenAPI contract and makes it simple for you to call API endpoints by the operation name. Testing tools. In fact, I just updated this week because my colleague, Holly Cummins, had pointed out to me a little while ago that Atlassian has a repository full of what they call Swagger request validator libraries. And they have implementations for Spring MVC, Spring Web Client, Rest Assured, Packed, and more. And what's really great about this Atlassian toolkit is that, let's say you're writing a Rest Assured test. At the top of your test, you can just import your OpenAPI contract. And then in your test, all you have to do is call the endpoint without anything else. You don't have to make any assertions. You don't have to add any other logic. And it will validate all of your rest assured requests against that OpenAPI contract and tell you whether or not you're valid against that contract, which is fantastic. There's similar tools for Chai on the JavaScript side to be able to do response validation. Haikaku is I'm trying to remember. I haven't really used Haikaku much. I believe Haikaku is also a JavaScript tool or a Ruby tool. Assertable is a Java tool for doing assertions. It can also consume an OpenAPI specification. So now we are ready for a quick demonstration, unless we have questions first. All right. So first up, I want to point you to the OpenAPI generator.tech site. So it's openapi-generator.tech. And as I mentioned earlier, these are all of the client generators. As you can see, it covers pretty much all of the common popular languages. And what this does is it generates a client library to interface with your OpenAPI or your API contract. And then you have the server generators. And I do want to call out, for example, under the JAX-RS server generators, each one of these has parameters to cover different JAX-RS implementations. So for example, if you wanted to generate a Quarkus JAX-RS implementation, you'd use JAX-RS spec, and then down here under one of the parameters, you would choose the Quarkus library, and it would generate Quarkus compatible JAX-RS code for your OpenAPI. Oh, I don't think I'm actually sharing my screen right now, am I? Apologies. Entire screen, share there. So I apologize. Um, OpenAPI generator.tech. There are lots and lots of generators for client, as I was saying a moment ago, lots and lots of generators for servers. And what I find really interesting is there are documentation and schema generators. So you can generate API documentation for your customers, for your end users, for your partners, and you can actually generate schemas for other different types of uh, API implementation, which is quite interesting to me. And then Atlassian Swagger Validator. So here is the website for the Atlassian Swagger request validators that I was talking about a few moments ago. And say, for example, you're a Spring MVC developer. What you can do is in your test, you can add in your configuration, you can define a validation filter, and you can load your OpenAPI specification into this validation filter, and it will make sure that all of your requests response for your Spring MVC app are valid against your API contract. Similarly, you can do for testing, you can go to the rest assured implementation. And at the top of your test, you'll do this OpenAPI validation filter setup where you load your OpenAPI specification. And then all of your tests from then on, when you start from given, when, then, inside of rest assured, will be able to use that validation filter. So you don't really have to do a whole lot of effort to get a really good test of your API contract. So I like both of those quite a bit. Now, I spoke earlier about the idea that you could start with building a validated user experience first. And what I want to show you here, what you'll see here is I'm running a Node.js project. This is actually using Vue.js for the front end. And in fact, this is, hold on, localhost 8080. This is a bill tracking application that I've built using these contract first approaches. Now, what you'll see here is that the response data is somewhat randomized, including the user identities and things like that. All of these are actually making calls to a REST endpoint or REST endpoints. More tools. developer tools. So if we switch over here to look at the network tab, you'll see that when I click refresh, it's actually making requests to the income endpoint. What's interesting about this, the income endpoint in this case is not something I coded. I didn't build it. I used a tool called Prism. And what Prism can do is uh, AS code. 1 second. What Prism does is it reads your OpenAPI specification. Let me zoom this in. Oh, okay, I am not a big fan of Mac. There we go. What Prism does is it builds a mock API based on our OpenAPI specification. And we mentioned earlier that there are these extension capabilities within OpenAPI. So if we go down here and look at some of our data, we will see things like, well, here's some extensions. I've added extensions to allow me to insert my Java field annotations and my class annotations. And I use that in my customized templates. But also, you might see things like this, X-Faker. So Prism will read these X-Faker extensions and will generate more realistic fake data for your API. So instead of just getting lorem ipsum or random numbers, you can actually get things that look like a company name or things that look like a person's first name or last name. And that allows you to more accurately emulate a real user experience as you're doing the development of this. So, for example, here's Xfaker creating a name instead of just a random piece of text, things like that, company names, things like that. So, what we see here in my browser then, this is all talking to a mock API that I had to write zero code for. And so I can continue working on this user experience, interfacing with my customers, interfacing with my end users, getting feedback until they're happy with that validated user experience. Only at that point can I take that open API contract that I've been iterating on and I can hop over here onto my command line. I can run I got to go up one level. I can run a command or OpenAPI generator, and let me command plus, kind of hard to see. Oh, so I can run this OpenAPI generator command. I want to use JaxRS spec, and I want to use the Quarkus library. I can input my OpenAPI specification file, and I can tell it where to output. And in this case, I only want it to generate interfaces, and I'll show you why that is in a moment. So I already ran this command just now. I can rerun it, which is great, and go into my budget Quarkus, Java code, open this up in Visual Studio Code, and what you'll see under Source Gen API is all of my controllers and all of my endpoints defined with all the appropriate annotations, all the Swagger annotations, all the appropriate parameters, all the appropriate documentation. Oh God, until I haven't run VS Code on this machine recently. And from this point, for me to actually make this a real implementation, all I have to do is highlight this and say, go to implementation or, uh, oh, I don't know how to do it in VS Code. Uh, in IntelliJ, you could just control space and create implementation, but I'm not certain how to do that in VS Code. So all I would have to do is create an implementation of this. I don't have to copy any of these annotations. They're already on the interface. They're already defined. I don't have to do any of the boilerplate required. All I have to do is create an instance of that interface and fill in my business logic. And that is a huge gain in productivity. Also, it allows those front end developers that constantly complain you're giving them the wrong data or they have to do more requests than they need to or things like that to help you understand exactly what they need to produce that user experience for their end users. So it's generated all API endpoints and controllers. It's also generated all of my POJOs for the different schema types that I've created. So, for example, this currency enum or the income object, and it's annotated them appropriately for my needs based on what I've put into the API contract. So then down here inside of main, all I have to do is create new folder, source main Java, and create com, Red Hat, consulting, budget, API. And in that folder, I can then say new file, uh, bills.java, bills.impl.java, and I can say extends uh, no, that's the model. I don't want the model. Bill AP. Yeah, Bill's API. Uh, oh, implements. Jeez. Really have been programming Java longer than a few days, I swear. So now it's going to tell me that I need to add the appropriate implementations. All I have to do is go in here and add my business logic. Now, of course, for databases or whatever, I'm going to have repositories and DAOs or whatever. But I just plug those in here and I'm done. And that's a really, really powerful thing to be able to do. And then I can use those tools that I showed you earlier around testing to very quickly be able to be sure that what I've implemented is working and valid with that API. Furthermore, once you get to that point with um, uh, having a real implementation, this same Prism tool that I mentioned earlier for the UI can actually run in proxy mode. And you can point it at a real implementation, and it will tell you if the real implementation matches what your OpenAPI spec has. Uh, all very cool. And all of this is really around the concept that we can save rework, save time, save frustration, and improve collaboration and communication across our various different teams. So we've seen how we write the specification. We've seen how we can generate a server. I didn't show you how to generate a client. Let me do that real quick. So for example, back here on my command line, I can go up and instead of generating the let's do budget Axios. And the output will be, the generator will be TypeScript Axios. And we generate this, and what it gives us is an API that we can immediately import into a user interface. And the example I showed you earlier with my JavaScript UI generates the API client under this SDK folder. And wherever I need to make a call to the API, anywhere in any of my components, in any of my pages or whatever, all I have to do is say API.operation name, and I get inline IntelliSense help on what parameters, what fields, what types are needed to be put in there. I don't have to think about endpoint names and paths and whether it's a path parameter or whether it's a query parameter. I'm completely and happily oblivious to all of that because OpenAPI Generator created the client SDK for me. With that, I think that covers everything, and I will open it up to questions. And I will stop sharing. Ooh, I came in a little under on time, didn't I? So please ask questions if you have them. Ooh, actually, one last thing. If you go to this website, appdev.consulting, redhat.com, my team actually publishes a bunch of tutorials and videos on that website. There's an entire section on contract first that covers different capabilities like getting started, using the testing tools, using the code generators, using things like Prism. And then there are more specific sections where we talk about various different cloud native runtimes like Spring, Brute, like Quarkus, like Vertex, and how you can apply contract first as well as other things in there. So please feel free to check that out. There's no registration, there's no nagware, there's no spam. Just go enjoy. There are YouTube videos for most of the tutorials, as well as hands-on descriptions of how to do the tutorials. And we'd love your feedback. It's all open source, of course. So if you find things that are incorrect or you would like to improve on, please feel free to go on GitHub and submit pull requests for that site. We'd be happy to have your input. So there were questions in the chat. Uh, How could you structure your front end to be able to generate the code from the OpenAPI file that exists in the backend, if I understood it correctly? So OpenAPI generator doesn't have to only use a local YAML file. So let's say, for example, you did go code first for your backend and you wrote all your code and you're generating an OpenAPI contract using like Swagger annotation, for example. You could point your OpenAPI generator or things like the Smart Recruiters Contract First library or the Vertex Web API capability. You can just point it at the URL for your Swagger contract that's generated by your code. Um, that gets a little dicey though, because if somebody updates the implementation that's deployed that you're pulling the contract from, and your generator runs, it might break your CI or it might break your application. So we generally recommend that people have either a mono repo that they have all of their various different projects in, as well as the OpenAPI contract, so that they can somewhat stay in lockstep with one another, or at least stay coordinated with one another. Or we have the OpenAPI contract in a separate Git repository or version control repository, and then you can refer to it either directly or use something like the Maven SCM plugin to pull it down. We've done all of those depending on different customers, use cases, and environments. Does that answer the question? Talked a lot about provider-driven contracts. What are your thoughts on consumer-driven contracts? Uh, it, I suppose it depends on how you define a consumer-driven contract. As I said, OpenAPI, gRPC, all of those are ways of describing interactions from one side to another, a server to a client, client to a server, server to a server. So I don't really see a whole lot of difference between a producer driven contract and a consumer driven contract in that case. If you write an OpenAPI specification and you feed it into a tool like the Atlassian Swagger request validators, uh, and you use, say, the packed implementation there. Is that validating a consumer contract? Maybe. Um, but if you have any follow up there, I'd be happy to try to address. Are there any other questions in the chat that I'm missing here? Oh no. Anything else? Anybody else? So as in the consumer defines the contract for the integration, the client tests through client tests produce a contract the provider validates against. Well, I think that's exactly the workflow I was describing with creating that validated user experience, right? As the front end or the user experience developer, even if that user experience is just an API, you're writing that to suit your needs, and then you're handing that off for somebody else to implement and be in compliance with that contract, right? So, what are the drawbacks of this approach? I guess one would be the mismatch in API version between server and client. That's so, at least in my experience, one of the best practices around REST APIs is that you should always version your APIs. For example, I generally put like API slash v1 slash whatever endpoint at the beginning of my API. And I do not change those version one endpoints in any way that could be breaking. So if I need to make a new endpoint that doesn't exactly work with the version one endpoint, I would probably put that under API slash v2 so that it's not a breaking change against the original API. And then I would mark that version one as deprecated until I can be sure that all of the consumers of that API are no longer in need of it. Versioning your APIs is absolutely vital, especially if you're going to have public consumers. You can't break and deprecate public APIs easily or quickly. Oh no, 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 no. Adding a new endpoint or adding a new field to a type or a schema inside of an open API contract, when you generate the code, it just works. There's absolutely no concern there. Either on the front end TypeScript side or in the Java side. I've done it with Ruby, I've done it with PHP and Python. It just works. So as long as you're not changing the type of an existing field or deleting a field. Now, if you do that, that is definitely a breaking change. Uh, well, it can be a breaking change. So if you're changing from an int32 to an int64, the Java generators aren't going to care. But if you're doing that in, say, C or C++, you might have a problem. Does that help answer the question, Max? Thanks. I appreciate it, everyone. Thank you very much for attending the talk, and I hope you enjoy the rest of JFocus.